Hello grade 12s, welcome to my channel, and hopefully this finds you well and ready to practice some more mathematics that is of some significance, honestly speaking, because it really is challenging, but it has some very wide applications that may put you some good positions later on. I know, guys, I have been away because of some serious family responsibilities, which unfortunately I could not shake, and I could not couple with these tutorials that we almost always have. So essentially they had to be on the back seat a bit. But now I am back, so tomorrow 7 p.m. we resume our tutorials, especially intense revision for those who will be writing the May-June exams. Otherwise, those who are preparing for their term 2 exams, this is perhaps at the right time to appreciate while learning other things as well. Now let's have a look at this worksheet. Of course, this came from a student. There were some questions they shared with me for some insights. So I felt this is good to share to the rest of you in this channel. I'm not aware of what material these questions came from, but I just took them and sort of compiled some worksheet for you to appreciate some technicalities that one needs to work through to get to the end of this whole topic, much stronger. So if you're interested in this worksheet, check the description to download a copy for yourself, because I'm not going to answer all these questions. Most of them are for you to practice, but I'll demonstrate similar questions. I'll do one, you do the next, I do the other one, and you do the next. If you come across some difficulties or challenges, do let me know. I may be able to help you as promptly as possible. Now let's look at this question 1. Now, in question 1, we are given information that in the sketch alongside, AB is parallel to PC. Okay, you can see there's AB is parallel to PC. And we are also told that PA is to AQ. PA is to AQ. So what I often do here, I show it like so and like so. Now, this is 2:5. So this means if this is 2A, this must be 5A. Remember, it's not 2 units. It's just 2 portions of whatever A is. Okay, so essentially this is what you do. So you always choose some multiple to create this proportion, to avoid assuming this ratio simply means just 2 units over 5 units. Not necessarily. This may have been a simplification of, say, for example, what can we say? This could be 50. Is it 50? I'm trying to think now, but it's not happening, and I'm like, why? Why is it not happening? This is probably 4 over 10, right? Because 2 goes 2 times to 4, and it goes 5 times to 10. So this could be it. So it may have been 10 units. Sorry, 4 units is to 10 units. But then this simplified to this 2 is to 5. Because remember, this is the most simplified version of what this could have been. So it is wise to avoid saying this is 2 units is to 5 units. Rather choose a multiple to keep them in proportion. Great. So that's what is the first step that we need to do. And BC is to CR. So we've got BC is to CR. Something like this. Now we have 4 is to 9. Now this means this is 4B is to 9B. Again, choose a multiple. Do not assume this means essentially units directly. This is the simplified version. Think of chemistry when we're doing empirical formula versus molecular formula. This would be the most simplified, which is the empirical formula, but it's not the actual molecular formula. All right, great. So that's the first thing one does. Okay. So obviously for proportionality theorem, we know that one side may be drawn parallel to the one side of a triangle. It therefore would cut essentially the opposite sides in the same proportion. Okay. So let's have a look. What triangle do we see here? So there we have a nice triangle, PQC. And we can see it fits very well into the proportionality theorem as we know it. Okay, so that is very important, because every time we are working with these kinds of issues, we need to at least be able to identify what we see. Then start to strategize on how to get the rest of it, because the questions may not necessarily be so nice as you wish, but they may challenge you to the core. All right, so let's have a look. We are supposed to determine QB, the ratio of QB is to CR. QB is to CR. Okay, so now we can see that QB we don't know. At least we know BC is to CR. Therefore, this divides into 4B is to 9B. Now, this simply says we need to express QB in terms of something, all right? And this something needs to be in terms of B, because we already have this one nicely. So if we can express QB in terms of this situation, then we could be good. So how do we do it? We need to work in this triangle first so that we can express this in terms of B. So this is as good as that. So we will say 1.1. In, please state the triangle working for you, and so that we can see if what you're doing is correct. We don't just want people jumping in and then talking about a proportionality theorem where we don't see exactly how does it apply. It simply says you are not serious and we must take you down. So first of all, what do we know? We're interested in QB. So we can say QB over BC must be equal to QA over AP, right? Because this fits well into the proportionality theorem. So we say this is the prop theorem. We always state what is parallel. AB parallel to PC. So now this is valid because we stated what triangle we're talking about, and we're stating parameters within the triangle that satisfy the proportionality theorem. So this statement and reason, remember, it's mark worthy. It has to come out. Don't start substituting. And in fact, annotate the diagram like I have done. There's no need to explain what I have done. Just show it on the sketch and it will make sense to the marker what is going on. Okay. Now, what are we going to do? We simply substitute. So we know that our target is QB over. Now BC is 4B. So don't show up with 4B that we don't see on the sketch. Remember, every time these questions are asked, there is a diagram sheet for the student to annotate and present with the answer sheet. So QA, we saw that it's 5A divided by AP, which is 2A. Now the good thing is that the A's will essentially divide to 1, and 1 doesn't change that ratio. So what do we see? We will see that QB over 4B is just 5 over 2. Now we cross multiply the 4B. We will then be able to find QB in terms of B, the small letter b. So we will see that 4 multiplies there, then 2 takes the 2, it becomes 2 times 5, that's 10. So we get 10b. Do you see how nice this is? Very interesting. But of course, you can put it on the calculator and essentially just check what this comes out as. So if you multiply this to 4, we get 10. But remember, the b was alone, so there is the b. So what do we say? We can simply say, therefore, QB divided by, okay, maybe let's start nicely. Remember, we needed to find QB as a means to an end. Then we will say QB over CR is equal to, now we write QB is 10B over CR, which is 9B. Now magics take place. The b's divide to 1. We can say this implies that QB over CR is 10 over 9. Now remember, how was it asked? Like that. So we need to make a conclusion therefore that QB is to CR should be equal to 10 is to 9. That's how we answer this question. Okay, so don't be afraid of writing a lot. Sometimes I'm against the answer sheet as it is provided usually for paper 2, because their students are constrained to summarize things. At the same time, one wants to learn that these students understand what they're doing, which is unfair for me. You should be given a booklet. You write where you want as much as you need. Okay? Let's stop this nonsense in this country of making people some kind of robots. Yes, for the marking becomes a bit challenging, but unfortunately that's just the work that needs to be done. And if you need the marking to be efficient, hire more people. Stop abusing the system. People need to get paid, and dearly, for the work that they do. And of course, we need quality. It's not about just trying to get through the motions. Anyway, that's me talking too much. So for the statement and theorem and reason, we always get a mark, sometimes 2 marks, because we are being particular to a particular triangle. So perhaps if this was to be allocated marks to create this ratio that is correct in relation to this particular triangle and furnishing an appropriate reason, usually 2 marks, but sometimes just 1 mark. Okay, so the rest of it all doesn't really matter, guys, but what matters is finding QB in terms of B. All right, and then the last mark is for the answer. The rest is just a means to an end. So I can give you 4 marks here, but you may very well get just 3 marks. So essentially this is just me being generous. Mostly this would be 3 marks. Okay, but let's just work through it nicely so that you can appreciate what needs to be done here. So let's do 1.2. 1.2, we need to find CR is to QC. CR is to QC. Okay, and as you can see, we already have CR in terms of B. So this means we need to find QC in terms of B. So this is very easy. We will start in the same triangle, PQC, to then work out QC in terms of B. So we'll start and say in triangle PQC. What do we see there? Well, we know that we are interested in QC, so we know that QC over, we can say this QC over BC, which is what we have there. Remember, with the proportionality theorem, we can choose however to divide those sides. Now, if we chose QC, it must be QP over same AP. Okay, we just need to be consistent here. Again, this is the prop theorem. We always state what allows us to use the proportionality theorem. which is that AB parallel to PC in that particular triangle. So please state the triangle that allows us to work nicely, and then we continue to answer the question. So this implies that QC, which is what we're interested in, over BC, this is 4B, is equal to QP. Now QP is going to be 5A plus 2A, right? Because it's QA plus AP, all divided by essentially AP. Did I say AB here? That was meant to be AP. Sorry for that. I'm sure you guys picked it up. So this is 2A. All right. So this also implies that QC over 4B is essentially 7A over 2A. Now the A's do us the honors of dividing to an invisible one, and after that we cross multiply that. So we'll see that QC is going to be equal to, now when we multiply by 2 there we get 14B. Okay, very interesting. Okay, so again guys, this is all about a strategy. It's all about strategy. If you don't strategize, you will not make it. Then what are we interested in? CR over QC is going to be 9B over 14B, isn't it? Yeah, and this does it for us. So what do we end up with? Let's conclude here. Therefore, CR is to, the way it is given, QC must be equal to 9 is to 14. Of course, if there was a common factor between the two, we would be able to do something about it. But at this point, we are not able to do that. Of course, in the exam sheet, perhaps you may want to divide this into two parts so that this answer is clear where it's coming from, so that no one reads it that you started here and then you just jumped here. Where did we see the statement? So essentially it helps to separate things so that nobody sees a continuation that is not a continuation. It almost always can fool somebody as to what is going on. So let's try to do it. Don't know why this thing doesn't want to be when I go 90 degrees, but this 90 degrees looks strange, but it looks okay now. Okay. So yeah, if you've had to write like that in a staggered way, let there be a separation so that we can see that these steps are moving along and going across like that, instead of this one going there and then down there. So we don't want to create confusion. So simple things, guys, make a difference. So pay attention to the utility of drawing some dividing line in some space that's available for writing answers, in case everything is misleading. Okay, let's see how many marks would a student get here. Again, statement and reason. Of course, this is the same question. We're using the same theorem. We may give you a mark because of being particular about the ratios and furnishing an appropriate reason. But this is strictly 1 mark. But QP had to be a calculation. You either get a mark here or you get a mark here. It depends on how the examiner wants to see it. It's not a big deal. And then, of course, getting QC in terms of B, small letter b. That's very important. And eventually presenting the answer as it is required. So this is 4 marks. Of course, I'm being too generous. Markers may not necessarily give the mark for this calculation. It could roughly be just 3 marks. All right. Okay. So essentially, guys, you can see that with proportionality theorem you need to strategize, and the strategy has to be very clear from the word go so that it is not confusing. So for you as students, have a look at number 2, which I think is very interesting. And you may want to have a look at questions like number 3, which I think is a bit technical as well. And yeah, there's a lot. Okay, maybe let's do number 3. I think number 3 is quite interesting. Let's do number 3 and then choose one of these ones where one has to calculate an area, because these are some of the questions that perhaps give students a headache in the exams. So do number 2 using the same strategy as I have shown you. But now let's have a look at number 3, which I think is a bit technical. It's worth discussing together. All right, so this is going to be a beat. So let's try to work through it systematically. Remember, you learn by observation, usually. But some of you can learn by themselves. But remember, you don't learn if nobody demonstrated something. So the purpose of me showing you what to do here is so that you can learn properly and do the right thing. Anyway, let's have a look at this. In the sketch alongside, NR is parallel to LM, as we can see. Kn is to NL. Kn is to NL. So again, please always show this as best as you can. Kn is 5. So if this is 5a, this should be 3a. Okay, can choose any variable, but take care to make it small letters or lowercase, isn't it? Great. So because this is to say it's not necessarily 5 units, it's to 3 units. This could have come from something else. Okay. This could have come from something else. For example, this could have been 15 over 9. Okay. 3 is the common factor. It goes 3 times to 9, 5 times to 15. So it could have been anything bigger, but that simplifies to 5 is to 3. So be careful. So it's always safer to use some sort of a multiple. But if you choose one, let it be in small letters or lowercase. All right. Don't use capital letters. Although you are at liberty to do that, but avoid them, just to make this workable and smooth. All right. And we are also told that LP is, okay, here I'm just going to write it out. LP is 6, but let's say this is 6y, is to 7, which is PQ. So this must be 7y. Okay, just remember this goes with the length. Because it's inside, I'm unable to show the way I normally do. As long as this is very clear. Again, folks, what matters here is to choose some multiple that makes them into proportion. Okay. Now, we can see there's 2 triangles that we need to deal with here. Before we even start working. So let's show those triangles. Okay, so we can see that we have a blue outlined big triangle KLM over the shaded small triangle QLM. All right, so this is great, and we can see the proportionality theorem applies to both triangles. So that's what we're going to need. Now the question says we need to determine QM, right? QM is to KR. Can you see this? So there's a crisscross here. We need QM is to KR. Stuff like that. Can you see? Now this is crazy because it's already suggesting we are in trouble. So we will need to represent something by something here. So the strategy to do this for me is to check what is common to both these two triangles. Well, sometimes it may not be too obvious. But if you look at QM or even KR, it doesn't matter which one really one looks at. It's either we look at KR as common because we can see KR includes a portion of QM, or we can choose QM because it also includes a portion of KR. So I will choose QM for me. So how do we use QM to deal with these issues? It means if we already have QM, our task is to showcase KR in terms of QM. So that's what we need to do. We show KR in terms of QM. Again, it depends. You can choose to show QM in terms of KR. It doesn't really matter as long as the strategy is clear. Okay, now how are we going to be able to do this? Well, it's not too difficult, but it is certainly challenging. Now we need to strategize. Let's look at this big triangle. In the big triangle, we literally do not have QM if we say we are going to use the big triangle, but we will definitely have KR. Right, we will definitely have KR. Now, let me see again. In the small triangle, we have QM, right? We will have QM over there, and we have RM. Okay, that's not a big deal. But now RM looks like is common to the two triangles. Can you see? Because RM is the one that we need to use. Because RM is part of the big triangle, right? When we use the proportionality theorem, it also comes up when we do the small triangle. So technically this is the correct one to choose, because QM didn't seem to be common to both triangles in terms of the proportionality theorem. So RM is our friend. If we represent everything in terms of RM, we stand a chance to win. Okay, not a problem. So now it looks like we're going to have to use RM in this business. So it doesn't matter which triangle we start with. We want to represent QM in terms of RM, and we want to express KR in terms of RM. Okay, so let's start. In triangle KLM, what do we see in this triangle? We know that our interest is KR, so we say KR over RM is going to be equal to KN over NL. Okay, this is because of the proportionality theorem, and we must always state that it's NR parallel to LM in that particular triangle. So this implies that KR over RM, RM is what we want to represent this as, is equal to KN, which is 5A, divided by NL, which is 3A, and then those ones do us the honors, and we cross multiply RM, so we can make a conclusion that therefore KR is equal to 5 over 3 RM. So this is very good, because our target is to represent our business in terms of RM, since RM is common to the two triangles. So always look for the common side. that is present in the both triangles or in two triangles. But at times it can be very challenging because it's not so easy. Okay, now we will say here also in triangle. Perhaps we can say likewise. I like that statement. But this time we're going to place reference in another triangle. Perhaps let's just say something else. We can say likewise, because we're still going to use the proportionality theorem. We know that essentially we want QM this time. We know that QM over RM. Because remember, we want to also express QM in terms of RM. Okay, must be equal to QL in the other triangle over PL. Okay, so what is this? This is the proportionality theorem with PR parallel to LM in triangle QLM. Remember, this time we're not using that triangle KLM. So it is safer to express which triangle this is, to avoid saying in triangle this is the case, and then in triangle this is the case. But again, you can still do it. It just depends on how you want to do this. So what does this imply? It implies that QM, I don't know why I'm writing B, over RM is going to be equal to QL. QL is going to be 7y plus 6y, all divided by LP or PL, which is 6y. Nice and easy. So simplify further. This means QM divided by RM is equal to, this is basically 13 over 6. Right. Okay, because, okay, let's just write it. Okay, so these ones will do it nicely. And we just cross multiply RM. What do we see? QM is basically 13 over 6 RM. Can you see? We represented this in terms of RM. Now we can have a nice ratio. We can say then we understand that QM divided by KR directly this time it's going to be 13. Okay, let's just say 13 over 6 RM, all divided by 5 over 3 RM. And guess what? RM takes care of RM, and the ratio will just simplify itself nicely. So we have QM over KR is equal to, remember when we have a division, we just simply multiply to 13 over 6 with this one flipped, right? So we know that 3 goes to 6 how many times? 2 times, right? And then that 2 that we remain with will multiply the 5, it becomes a 10. So this becomes 13 over 10. Okay, but again, you can put it on the calculator. Let's check. Sometimes it's easy to, mess up everything. Just write it as it is, divided by 5 over 3. And then let's see, we get 13 over 10. Okay, so what is that? Remember, the answer is to be presented the way it's given. So we will see that QM is to KR should be equal to 13 is to 10. Nice and easy. Okay, as you can see, guys, sometimes you've got to look for the common side to two separate triangles that can apply the proportionality theorem, and we simplify one in terms of one common side and get our marks. So obviously for statement and reason we get a mark. we get a mark for that KR in terms of RM. Since this is similar, but again in a different triangle, okay, perhaps it's a mark. And what matters is to express QM in terms of RM. And we simply get those marks. So this is 1, 2, 3, 4, 5. This could be 5 marks. As you can see, it's a bit naughty, but at times you may be given just 4 marks, but certainly not less than 4 marks for a question of this nature. As you can see, guys, this is an essay type question. It's not easy, and it's also not easy to see what to do. When there's an overlap, try to look for the common side to perhaps 2 structures that make sense to apply a known theorem, and then work through it like that. All right, great. So we have some info that we can use to our advantage. So let's do 3.2. Now 3.2, we've got KQ over RM. Okay, so can you see we've already shown everything in terms of RM. So this simply says we need to show this KQ in terms of RM. So how are we going to get to that? Now this is where you see again that we have a big challenge, because this simply says we need to find KQ in terms of RM. So how will we do it? Let's look at KQ. KQ is nothing but perhaps KR minus QR. Okay? So we showed KR in terms of RM, which is 5 over 3. Okay, we have it. So if we can show QR in terms of RM, then we'll be able to take the difference and then work it through. So this looks like a plan. So let's have a look. What are we supposed to do? Now, we will see that essentially in triangle QLM, what we have there, we are interested in QR in terms of RM. QR over RM should be QP over RM. No. What am I doing? PL. Okay. Again, we furnish a reason. Prop theorem with PR parallel to LM. All right, not a problem. This implies that QR over RM is equal to QP is 7y divided by PL, which is 6y. And of course, the y's will do the thing, and we just cross multiply our RM. Can make a conclusion that QR is going to be 7 over 6 RM. All right, now we have it. We can say, but we understand that KR, or let's just say KQ plus QR is equal to KR. That's very clear, because if we take that segment and we add that segment, we essentially have KR. All right, so this implies that KQ plus QR is now 7 over 6 RM is equal to KR. What did we find it as? It was 5 over 3 RM. All right, so we then transpose, because we've got like terms. Now we know that KQ is going to be 5 over 3 RM minus 7 over 6 RM. Okay. All right. Okay. All right. Now, Tell me which one is bigger between 5/3 and 7/6. Just look at the distance between the two. From 3 to 5 we've got 2 units. From 6 to 7 is just 1 unit. So this one is smaller. Right? You can even put it on the calculator if you are not so quite sure. But now what I know is that definitely this is a smaller ratio. So the common denominator is 6. Then we say 6 divided by this is going to be 2. 2 times the numerator, that's 10. 10 minus 7 is 3/6. Now 3/6 is a half, so we just write it as such. So again, importance of rough work. When working this out algebraically or arithmetically, technically, you can just do this on the side and the simplified version is written there. So let's see. 5/3 minus 7/6 is indeed a half. Okay, you have a calculator, verify the answer so that you do not present an answer that's wrong. Can you see? Once we have expressed KQ in terms of RM, it's then easier to perform this ratio because RM is already there. So we will write. Then we understand that KQ divided by RM as it is essentially, what is KQ? KQ is 5/3. No. What am I doing? Is a half RM all divided by RM, because RM is as it is itself. So we'll just write RM yet again, and guess what? We get the matrix. That's the case. And so what do we have here? This implies that KQ over RM is going to be, obviously this is divided by 1, so it's just a half. So what does this mean? This means that KQ is to RM is 1:2. Okay. So this simply means KQ is a half of RM. Can you see these ratios work themselves out nicely? No matter what strategy one follows. Again, these are the essay type questions. Very challenging in nature. So sometimes it's not so fun. But yeah, we've got to deal with it. Anyway, I think this is too long. It's best to cut this video and perhaps do one video on one of these two questions separately so that we don't end up with a very long video. But again, it's nice to do just one video to assist the student to perhaps appreciate the level of thought within one space so that you don't have to look around too much for these videos. But yeah, it just depends on how one wants to see it. Anyway, for statement and reason, we get a mark. Representing QR in terms of RM is key. Now this gymnastic is pretty straightforward, but what matters is that answer there and the final answer. So we have 1, 2, 3, 4 marks. As you can see, this would be worth 4 marks. Alright, so I hope you guys are cruising on very well indeed. But sometimes, to not lose you, I will cut this video here to avoid working too hard, because I would love to show you guys some things here so that you can work through them nicely. But yeah, it is the way it is, man. There's many questions, apply the same theorem. Sometimes these ones use the converse, essentially the converse of the proportionality theorem. So be in a position to use it and to answer questions. I think this one, because we have the ratios nicely given, it's a very easy question for students to do. But I would suppose question 7, it's a little technical. don't you think? Doesn't matter. But I think if I'm doing any question here, it's going to be this. Then you guys do the first one because you knew how to deal with the ratios when given. Maybe let's try and see if we cannot take down this question within this hour. All right, question 7. What do we have here? In the sketch alongside BR is parallel to CD. We can see it's indicated. And BC is equal to 5/13 BQ. Now, can you see this? Now, the way this is given, it's not making sense for a student. So always do something about it. If we've got BC is equal to 5, say, over 13 BQ, just divide by BQ, both sides, so that this is an easy ratio to see. That means BC over BQ is nothing but 5/13. Now this one is easier to deal with. It sometimes creates a problem when it's like that. So now we can do our job nicely. BC, okay, over BQ. So this is 5. So we can say this is 5A over BQ. This is going to be 13A. We always choose a multiple shown by those small letter symbols. Okay, so that is why I wanted to choose this question over the other one, because the other one, its ratios as we have worked with above, but this one, it shows us the ratios in a different way. So we need to simplify the statement given into ratios that we can recognize and then be able to use effectively. Great. So now we are also told that PB, this segment right here, is equal to BQ. So it is equal to that entire segment. So of course this one is a bit technical, but hopefully one can see if I place this point over there, I think seeing those two symbols with the same color clarifies the confusion. So there's ways of trying to present your work in a manner that is understandable, or at least easy to follow. Remember, you will be marked by a mathematics teacher of some sort. So essentially, those people also understand a bit of logic. So they will be able to follow as long as you express yourself properly, or at least in a clear manner. Even if one can be confused for a second, okay, what is that dot for? Just simply says that's the midpoint. And therefore, these lines, essentially it means BQ instead of just CQ, because here it's not easy to indicate these symbols nicely. So just place a dot there and then same color with those symbols, then someone will understand that B must be the midpoint. Okay? All right, okay. So guys, you don't rush. You set things up nicely. And then you start working systematically, following the 3-step approach. You make some rule or statement or whatever, theorem. Then you substitute. Then you work out what is needed, whether it's intermediate or it's the final, doesn't matter. But be systematic in approach, just like a doctor, which as a whole we call it a doctor's approach, isn't it? But it follows the 3-step approach of mathematical solving or problem solving, right? Well, that's what we do in maths, guys. There's nothing else. Whenever we solve a problem in maths, it's the 3 steps that I have shown you, and you can see their utility. It's pretty intense. Anyway, determine the area of triangle CQD. Okay, so there is our triangle CQD. Nice. Okay, over the area of triangle BQR. All right, which one is this? Okay, so we can see that it's this triangle over here, over that triangle over there. And we can see that the big triangle BQR has this line CD parallel to BC. So the proportionality theorem is going to work here. All right? Because technically, if that is the ratio, we know that this ratio as well should be a similar one. So if we've got 5A there, we will certainly have here, let's say 5B, then this should be is to 13B. Again, here we're just choosing a multiple to get it done. So obviously, that's the logic behind everything, because proportionality theorem always works like that. Okay, all right, okay. So now we are in a good position because they share a common angle Q. So this means we can use the area rule here. Right? Yes. We need the area rule here to work in our favor. But before we can use the area rule, this then forces us to know what this length CQ is. If this is 13 as a whole and then there's 5. So we'll just say 13 minus 5, which is 8, right? Yeah. So this should be essentially 8A. Logically, because I mean, if that's the whole length, this is the portion of it, then this should be the other portion. Same will apply here. If we've got 13 and then there's 5, this is going to be 8B. All right. So these are some of the things to think about. Of course, this is a bit technical because someone may ask, what the hell? Where did you get this? We have not justified it as yet. And as a result, we cannot just present our answers in terms of these without justification. We need to first justify this. All right, great. So what are we going to do? We will first get the justification for this in terms of what was given. So we'll say in triangle BQR. Okay, we're doing 7.1. Now in triangle BQR, we understand that BC, okay, is to BQ is essentially 5 over 13. That's what this means. Of course, one can just write this as it is given and then make a conclusion. Maybe let's try to show you the right way of doing things. BC is equal to 5 over 13 BQ. We can make a conclusion that therefore BC over BQ is 5 over 13, which is what we do. So that's what is important. Now, what do we want to end up doing? Well, it depends on the student. Of course, one may decide to use this as it is and then use those ratios. But I mean, I feel like once we do this, we are at liberty to do that, and it justifies our 8 over here. It justifies this portion once we show it like this, right? Right. Now, what do? We will say also, we understand that RD over RQ should be equal to BC over BQ. This is where the proportionality theorem comes in. We need to state CD is parallel to BR. Remember, we're still talking about this triangle. So at this point, we don't need to specify what we're talking about. But what we're trying to do here, we know that BC over BQ is the same. So we will say, therefore, RD over RQ is 5 over 13 as well. Hence, what we are doing. So this justifies everything, including this value right here. Okay. So we can annotate our diagram that way, because we needed to show that it's the same proportion first before we start annotating. We may have started with annotations, but we then justify in our arguments here. Now, we are at liberty to do what we need to do now. We can say then, we know that area of triangle CQD over area of triangle PQR is going to be equal to, we're going to use the area rule. It's half CQ times QD times the sine of angle Q, all divided by, remember, area rule, you must take this two sides and an included angle. Nice. So this is also going to be half. Now the side is BQ times QR times the sine of angle Q. Remember, whenever we're dealing with ratios, we need common things. So the angle must be common as we saw it, if at all it is significant. So we can clearly see that immediately sine Q divides sine Q into an invisible one. And so we move on. Oh, the halves as well do the same. They divide into an invisible one. One is a multiplicative identity, so it can be gone from the issues here. CQ, what is it? It's 8a. Well, we can see it. It's as simple as that. But if you like, you can show the calculation that it is literally 13a minus 5a. That's CQ into QD, which is, did I say QD? Yeah, that is 8a. Again, QD is as good as 13b minus 5b. Just to show those calculations if you want, but it's not necessary. We can easily just substitute. It makes logical sense that it is the case. Divided by BQ, that's 13a, multiplied by QR, which is 13b. Alright, so let's have a look. So this is 13 minus this is basically 8a times 8b divided by 13a times 13b. Now we can see once we have multiplication, these take care of each other nicely. So this is 64 over 13 squared is what? Is it 169? I'm not so sure. 13 squared, yes, it's 169. Now let's see. I don't think there's a way of solving this, so this is as good as what it is. So that's what we get, and we stop there. So we can leave it as a fraction. We cannot simplify it further. All right. So as you can see, guys, sometimes the questions can get a bit naughty. All right. They can get a bit naughty, but what is important is to strategize. First of all, this was given, yes, but it implies this, right? Right. So this is key. I would give a mark, although it's a small mark. It may be ignored. But what matters here is the statement and reason and that conclusion. Okay, but the conclusion is pretty much weak. Perhaps let's leave this one. The conclusion is not that big. All right, so using the area rule for the numerator and the denominator for me is key. And the substitutions here entirely and the final answer. So this is 1, 2, 3, 4, 5. Okay, maybe let's not give a mark. This one is not so strong. 1, 2, 3, 4, 5. 5 marks is fair. It's not so easy after all. All right, so this is it, but one could easily give 6 marks here, depending on how the examiners felt, or the quality assurer felt this question is worth, given what needs to be done to go through it. Okay, let's get to 7.2. Now 7.2, we need to find area of triangle QPD. QPD. Okay, this one right here. All right, now, and which triangle? RPD. RPD. Interesting. Now, can you see these ones have nothing in common? Because the angle here is not the same as the angle there, or at least we were not told it is so. Right? Right. I'm thinking, but I don't know what I'm thinking, if it is right or wrong. Okay, let's see it again. It's QPD. QPD. Okay. Over triangle RPD. RPD. So the side that is common to these two triangles is side PD, right? This is the common side. Now, and these two angles, this angle D over here and the angle D over here, are angles on a straight line. So we can represent this angle in terms of this angle D. So that's another common thing, because they share a common arm. These are adjacent angles on a straight line. So it is best to use this angle over here, the angles on a straight line, because those two angles are totally different. We will run into problems if we use it. But one smart individual may still say, look, this is adjacent angles as well, because we can say this whole angle, or at least we can say that particular angle is the whole angle minus the smaller component. We can still represent one by the other. So it really matters. It depends on the student as to what to do. But for me, these adjacent angles are the best to choose, because we already have identified this side. We've identified this side. This is the common side to both, and the angles can represent each other on a straight line. So this simply means we can use that knowledge and move forward. So we're going to say, okay, all right, okay. In triangle, let's say QPD, isn't it? Yes. In this triangle QPD, we just want to define this angle D in terms of the other angle. Okay, so we know that essentially in the angle PDQ, let's just call it that, PDQ is equal to 180 degrees minus angle PDR, or RDP, let's just say RDP, is izindlu zikahulumente. Why is that? These are angles on a straight line. It is important to do this, guys, because we will use this RDP for the smaller triangle. This is key. Otherwise, sizoba sengxakini. My God. Retloba qakehin, mathateng. All right? Yeah. Now, the only reason I'm doing this was just to show this angle in that particular triangle. Otherwise, I don't have other issues. So we can say then, we understand that area of triangle, what was that one? QPD divided by the area of triangle RPD. That should have been RDP, man. Aye. izindlu zasimahla zikatata urhulumente. Now we're going to use the area rule again. This is half. We want these sides. So this is going to be QD times DP times sine of angle, what did we call it? PDQ. All divided by, this is going to be a half. Again, we can choose, it's going to be RD if we like, times DP, it's a common side. Always choose common things, guys. Sine of that angle, which is PDR, right, or RDP. Ne? Because we know that the top angle can be represented by the small angle because sine reduction formulae, right? Right. So maths is fun, guys, if you love what you're doing. Of course, the magics happen there. The magics happen there. We wanted common things so that we can get rid of as many of them as possible. So now what is QD? QD is 8B, sorry, times the sine. Here we will substitute 180 minus RDP, all divided by RD is 5B times the sine of RDP. Okay, simplify further. This is 8B times sine of 180 minus, it's a reduction, same formula, sine positive in the second quadrant. So this is the sine of RDP, all divided by, this is 5B times the sine of RDP. Now the magics further happen. This is the same thing now. It all goes away and the bees do the thing. They just produce honey. And all we have now is 8 over 5. Isn't it nice? It is. So guys, planning helps a lot. Of course, if one chose this angle, it could have been a nightmare, right? Right, it could have been a nightmare because it creates a compound angle identity of some sort. Then you end up going through expansions and you don't want those things. They are not nice. Okay? They are not nice. So avoid too much work because the mark allocation also indicates the amount of work that is needed to deal with issues in there. Of course, guys, this is very important. Without it, we would be in trouble. And then, of course, for the same rules, using two triangles specifically, that's good. And essentially, the reduction formula here, it's very important. Remember, when we use our three-step approach, reduction formulae, we get a mark and the final answer. So we have 1, 2, 3, 4 marks. So this could be 4 marks, meaning no need to try and use compound angle identities here, which would be the case if we use that triangle. Maybe it can work, I don't know. Try it out and see if it works. So for me, it's always strategy. Whenever something is given, the first thing to do is to inspect it. A doctor who does not inspect his patients, he will never know what is going on to his patients. You know, I was presented to a patient, of course I'm not going to say the identity, but there's a patient who came to me with some problems. And I can tell you, from my inspection, I was able to see something the family never noticed. And this very same thing, okay, it's not really related to what I was thinking is going on, but at least it gave me some perspective. And from that perspective, we ended up uncovering what is going on nicely without pfeffering around and choosing the improbable investigation. Because of what we saw, we kind of chose the right investigation that actually revealed the right problem. But we're not really exact, but from that inspection, it led to something that led to actually the solution to the problem, or at least understanding what the problem is. So these kinds of exercises, yes, you may say, why do I do this if I'm not going to be doing this, for life? I'm going to become a doctor. You have a lot of stories to tell. I can tell you guys, geometry is very important. If you want to become an oncologist or a radiologist, certain angles mean certain things in what you call radiological investigations. And the radio-oncologists, meaning people who treat cancers using radiation, sometimes a certain angle from the surface to what the lesion is deep down in the body. You can choose certain conformations of your treatment plan to concentrate the most energy or the most photons to the center of the lesion. Of course, taking care of the distance it is from the skin surface to the depth of the body, and exactly how big in terms of volume that lesion is, so that you can create collimators around it that will focus radiation in 3D, that will focus the most energy into the center of the lesion, and that means destroying it from its core without injuring the surrounding brain, because where these photons coalesce, that's where they will empty their energy into the cells and damage them. But with the others, they go through, because of the distance from the source to the passage of these photons, they don't actually do anything to that cell, because it's too fast for the cell to even absorb any energy of any significance so that it can be destroyed. But where they essentially, where they disintegrate, or where they end, or where they empty all their energy, which is their end point, this is where they will cause the maximum damage. So all of these things, guys, they look like a joke, I promise you. But if you start to think hard and where this can lead you to, you start to realize that to become the best, you must already be the best right now. Because later on, you will start to find better ways of dealing with problems. Remember, you still have engineers. Some of your friends are going to become engineers. You partner with these guys. You have this idea that, okay, I've been treating this cancer, but hey, this one is difficult to operate on. There's more complications with surgery. How about we try and devise a way in which we can just deal with this radiologically, but now what do we have to make up for in our treatment plan? Then you come up with an idea of how to make a machine that can deal with that problem. That would need angles of some sort. Sometimes we use triangles to divide certain structures, so to know what is where. Because if you're going to drill bone, for example, looking for the cochlea, if there's a problem there, you need to know how to divide that petrous temporal bone. Even during surgery, you need to know how to divide it into some kind of triangles to know that in this particular triangle, this is where I will find my cochlea. Or at least if I make this angle, maybe I draw two lines, one, across the ridge of the petrous bone, and then perhaps one across some particular structure. If I make a particular angle, within that particular angle, I will have my cochlea right there, or at least in the proximity. So these are the things we use as surgeons to get to very, very, very technical and very small areas in the body with precision. It's all Euclidean geometry. Hey! So don't ask me silly questions as to when are you going to use this. There are some ignorant people who go around telling you, in my life as a doctor, I never used it, because they only listen to what they get told. Okay, they don't even understand why what they are told works. They just know it works because they've seen it work. Yeah, they'll go around, research shows, but what led to even that research? Because we need to ask those questions as well. Why did we even think about researching? It's because we had an idea that is far deeper than what the research will show. The research only shows the end result. It doesn't show us the underlying source sometimes, if we did not concentrate on uncovering it, of course, either as an associate or a close association, or at least the cause of what we see. Yeah, I'm saying a lot of things now. Sometimes my brain just accelerates ahead of me, guys. So, forgive the man. You know, the man is just too opinionated. Sometimes not good, Sometimes not good because I'm wasting your time, literally. Okay, let's have a look at the next question. We need to do the area of CQD. We've already worked with the CQD, the yellow one, over PQR. PQR. Now, the bigger triangle again. So, the nice thing about it is that they have a common angle. So, we don't need to stress, because once we have the common angle, we can see this side is already clearly defined. Why? Because BQ is equal to PB. So this is 13A, that will also be 13A. And here we know everything. So we are sorted. So this one, we don't stress, we just go straight into it. Area of triangle, CQD divided by area of triangle. I don't know why my writing is changing. PQR. We use the area rule here, half. Now this is CQD. We can just say CQ times QD times the sine of angle Q divided by half. The big one now is going to be PQ times QR times the sine of the included angle. Again, choose the angle that is common so that we can do elimination. The key with these ratios is to attempt to eliminate something. Obviously, the halves, they divide to 1, and 1 is invisible. Sine Q divides sine Q into 1, which is also invisible. So all we have to deal with is CQ. But now CQ, do I have CQ now? My lord. Oh yes, I do. That is 8A. So we already did work it out above. Multiplied by QD. Sorry, what is this? QD, yes. QD is 8B. Divided by, now we have PQ. PQ, we need to show it as a calculation. So this is essentially 13A plus 13A. Of course, one can easily say 2 times 13A because we knew that that is a midpoint. So maybe let's make it much easier. So this is 2 times 13A into QR. QR is a bit different. It's going to be 8B plus 5B. It's not 56, ne? Don't forget. Alright, let's just simplify now. We've got 8 plus 8, we've got 64AB. So that's a multiplication, so that's good. This is going to be 13 by 2, that's 26 plus 13. Okay, essentially this is 13 times 13, right? No, it's 26 times 13, or we can say A1. 10 out of non-pi is okay. Yeah, this is 26 times 13, right? Which gives us 338AB. Okay, because those ones are not the same. So this is 26 times 13, and then yeah, that's it. So what do we see here? AB takes care of AB. So now let's see, these are even numbers. There will be a common factor between the two. So 64 divided by 338. So it gives us 32 over 169. Okay, that's better. Nice. So this is it. So this one we went straight to it because there wasn't much for us to work in between and then get it done. It's just the setup that matters. How to set it up is what is important. Okay, so obviously the rules for each. Sorry, we get a mark perhaps because we had to work some things out. This was a working, it warrants a mark. This one is too obvious. We don't need to justify it. Perhaps one to just give a bit more marks. We can say perhaps the general substitutions after that, but what matters is the answer. But I think 3 marks is pretty clear here. What was more important was this, because we were told B is the midpoint of PQ in a way. The rest was too easy. Okay, not too big a question there. Now let's look at the next one. 7.4. We want CQD, which is what we already have, but now over PQD. PQD. Okay, so CQD over PQD. Again, we can see there's a common angle here. And we know this side, we know that side. So everything is good. So we can jump straight in. So 7.4. We can say area of triangle CQD divided by area of triangle PQD. This is area rule again. This is going to be a half CQ times QD times sine of angle Q. It's a common angle. Divided by half. Always try to use the common things. And then this one is going to be the half of PQ times QD as well, which is common, times sine of the included angle, which is angle Q. So the nice thing here is that the magics again continue happening. QD is common, does its own things, halves are doing their own thing. So this is as good as the ratio of these sides. All right, CQ is 8A over, what is that, PQ. PQ is 2 times 13A. Then of course with multiplication, they do it. 2 does it with 8 there, remaining with 4. So all we have here is just 4 over 13. Nice and easy. Not too complicated. Again, strategy. So obviously the rules for both triangles is key. And substitutions are too obvious at this point. The answer is what matters. This could be 2 marks, okay? Not a big deal. All right, guys, so this is great. Is nice. Is palatable. So do you guys want to do the last one for me? Some belief, doch, I'm tired now. Because I think after showing you the tricks, guys, it's you as a student. Sometimes ndike unibukele umntwana esikolo bese ndikushiyela nawukhukhuza amathambo, yabona. Yeah, man. CQD is still the guy. RPD this time. So can you see this one is different? But how is it different? Uzovumhlola ke ngoku. Okay, maybe mandingakushiyela ukhukhuze ngoba izakuxaka le, ngoba ezi azifani ngoku. And ke ngoku ingxaki yoba zingafani izawuba yi-problem enkulu, yabona? Ingxaki is a problem. The problem is matata, mas. So the matatas here is that these two triangles don't seem to have anything in common. But we saw that there was some link between these two triangles. So now we need to think about it. See the ratios we have been using above. We need to choose a ratio in which these two triangles shared in common. Because we saw that this triangle, this one right here, had something related to this one there, PQD, whatever. And we also saw that CQD had something in common with PQD. So in a way, we need to use those, because if we choose those things and we try to represent them in terms of the common triangle that they share, which is PQD, because CQD and RPD, they somewhat shared some ratio with triangle PQD. So we use those and we represent PQD in terms of the other one in ratio and as the other one in ratio. And guess what? Once we do substitutions, it's going to lead us home. So these are some of the higher grade questions. Obviously, this one is a higher grade question because it's not so obvious. Because now things don't seem to be okay. But again, these questions above have kind of led us into the answer somewhat. Because remember, this question can be asked without all these other questions. So what do? You choose what seems to share some similarities with it. Then you create an equation. So this is simultaneous equations. And we work through it. So we're going to pick from above some issues that will work in our favor and see if it doesn't lead us to the answer. Sometimes it's trial and error, folks. You never know what you're going to do. So let's go. We know that RPD, where did we have RPD? There it is. So we got RPD in 7.2. So what did we see? We saw that area of QPD, right, over the area of RPD, right, or RDP in 7.2, né? It was 8 over 5. So we take that answer. So this is proven above. Proven or proved above. Let's just say proved above. Proved in 7.2 to be exact. So that no one starts looking and be like, I don't remember saying it. So what do we want? We want to represent the area of RPD in terms of, of QPD in terms of RPD, because we saw that QPD is the common issue here that we want to work with. So what do we see? We just cross multiply with that. So we can say therefore the area of QPD is equal to 8 over 5 times the area of RPD. Nice and easy. That's equation 1, okay? We saw that also. What else did we have? At 7.3, we had this CQD and PQR. Wait. That was CQD. Okay, CQD corner la. I want QPD. Why do I have QPD? Yeah. QPD, okay. Before to QPD, there it is. CQD and QPD. So that's 7.4. Right? Yeah. Wait a minute. PQD. Did I have PQD above? Yes, I did. So 7.4 gives me the things I want. But this one came out a bit rough, so we're going to have to work a bit more. We knew that area of triangle CQD over the area of triangle PQD, which is what we want, QPD. Okay, I think here QPD, okay, this is the same triangle anyway, even if I write PQD, but let's just write it the way it makes a bit of sense. Maybe you may want to correct how I wrote it. It doesn't really matter. Again, examiners do this to confuse you because you get used to naming something in one way. It's still the same triangle. QPD and PQD is the same. So let's just call it area of QPD PD. This is equal to, what did we find in 7.4? We found 4 over 13. So now we will cross multiply first because we want to isolate QPD. So cross multiplication makes a sensible option here. So we will see that 4 times the area of QPD is going to be 13 times the area of triangle CQD, not just this. This is triangles. I'm becoming careless now. These are triangles, not just lines. Remember, when we write it like that, it's a line. Area of triangle QPD, area of triangle CQD. Okay, great. So remember, they are triangles, they are not lines. So if you don't write the symbol triangle, it's not correct. Okay, so this implies, or in fact we can make a conclusion. We just divide by 4 here. We can say therefore area of triangle QPD is also 13 over 4 times the area of triangle CQD. Can you see? What do these two ratios spell out? They spell out area of triangle QPD. Area of triangle QPD. So these two are equal. So we can say then it is obvious that this is the case. But now what do we want to be on top of the other? We want CQD to be on top. Ne? So we know that therefore 13 over 4 times area of triangle CQD must be equal to, we write that one, is going to be 8 over 5 times the area of triangle RPD. Can you see? Nice and easy, because they all spell out the area of triangle QPD, although it didn't really get written the same way, so that the student doesn't see the magics here. So obviously, folks, what is our task here? Now our task, we want this one below this. So we can divide both sides by, now remember, we want to eliminate this. So we must divide by 13 over 4 times the area of triangle RPD. What we do on the one side, we must do on the other. So it's going to be 13 over 4 times the area of triangle RPD. Now this one was a tough question. Of course, once we do this is good. Once we do that, the entire thing, area of that, area of that, they do the magics. So can you see? Life is now nice and easy. So we will say area of triangle CQD divided by area of triangle RPD should be equal to 8 over 5. Now this division line is as good as 13 over 4. Alright, so we can make a conclusion therefore that area of CQD, no, not just CQD, but triangle CQD over area of triangle RPD must be, so we just flip this. Now when we flip this business right here, 8 is going to multiply 4, which gives us 32. 5 multiplies 13, which gives us what? Yeah, ne? Doesn't go. Way, Mama Lord. So 8 over 5 sending that bed divided by 13 over 4. It gives us 32 over 65. And that's it. Okay, that was a nice question. Okay, one that makes simultaneous equations look nice. But again, you may have seen above, we did derive some simultaneous equations when we represented something in terms of Rm. Those are simultaneous equations. So higher grade questions almost always have some simultaneous equations coming. As you can see, this one, you cannot just do it directly. You have to do it indirectly. Of course, from those ratios, we could easily just take CQ, the area of triangle CQD, instead of what I did here, which looks a bit silly. One could easily have written these ratios and say, essentially, represent that QPD in terms of RPD. No. Maybe RPD in terms of QPD, right? That would be good. And then come here and represent CQD in terms of QPD as well. Great. And then this would be a very nice ratio when you do it directly. But this gymnastics is just to show you guys that there's many ways of killing a cat. Although it's very difficult to kill a cat, it's challenging. That's not an animal that dies easily. So it has what they call 9 lives or so. I don't know if it is true. But yeah, ich continue, man. So there are many ways. So try to represent one area of this triangle CQD in terms of what is common with this one here. Then you just simply have the ratio directly like we were doing above. Otherwise, guys, I hope you've enjoyed the video and you're gonna love it, because guess what? It's important. So this is key, I suppose, and that is key too. Okay. Now, technically, equating these two is nice, and the rest, guys, is your own issues. So the answer, so this is 1, 2, 3, 4 marks. Of course, there are many ways of killing this cat. It's a very difficult, okay, not very difficult, but it's a challenging question that requires some strategy. So I hope you guys are enjoying these tutorials, and hopefully they are going to transform you into a beast of maths. Even if you are going to do applied maths somewhat instead of direct maths, or perhaps you want to become a mathematician, which is good. We need any one of the people that you can become in the future, as long as that person you become is very good, because we don't want mediocre stuff here. Mediocrity is not what we're doing this for. We're doing this to enhance the very best, to become exceptional. Anyway, guys, I hope you're gonna enjoy this. Like it, comment if you have any challenges or issues following me, or perhaps doing the other questions, and also share it with your friends so that they too can see for themselves. Even if you didn't like the video, just share it so that they can see if within this rubbish that you probably deemed it as, will they find anything. All I can tell you guys is that you find the most valuable assets where you least expect them. Because where you do expect them, you find a whole lot of rubbish that you did not notice. It is nonsense. Anyway, goodbye. See you next time.